So we are going to review our techniques of testing an alternating series by using this simple example. So if I look at this series, we are starting with n equals 2 because n equals 1 is going to make this denominator invalid. So if we put n equals 2 here, what we have? We will have negative 1 square as 1. So we have 2 square root of ln of 2. Okay, and then we have minus, then we put n equals 3. That will make, that's why I got that negative sign, because negative 1 cube would be negative 1, and this is how this series will proceed. So now if we look at the series and we look at the absolute value of every term, what we notice is this, that all these values of the sequence given by this, they are all positive for n greater than or equal to 2, right? So, and we do have n greater than or equal to 2 here, and also as n increases, okay, and we are looking at the positive integer values of n greater than 1, okay, this sequence decreases, and also this goes to 0 as n goes to infinity. Therefore it passes the alternating series test and it converges. Now a question is how to find an approximate value of the limit that it converges to. And let's see, let's add the first 10 terms, we get this value, then 11 terms will give us, let's see what it gives us, then that gives us this value here. So of course we subtracted a term, so that's why the value went lower. So now we will will have a positive sign, so it will go up. So here we go, and well, let's go one more step, all right, to see the behavior. Okay, so here we are. If we do that, and of course is going to decrease, so became this. Now we want to know that how many terms should we add in order to get a desired level of accuracy for this series. Okay, so say we did this, we added the terms up to, all the terms up to little n equals capital N. So if we did that, then what will happen? We'll be losing all these terms here. Okay, that is starting from n plus 1, sorry about that, to infinity, right? Now we have a convergent alternating series, and for a convergent alternating series, what we have, that the absolute value of this leftover is going to be less than what? The absolute value of the capital nth term, which in this case would be what? 1 over n square root of ln of n. So now let's say we want to find a value of capital N, so that this has to be less than 0.001. Okay, it will suffice to find an n for which this value is less than 0.001. In this case, we are just going to go numerically. So let me just pick up this spreadsheet Excel. Okay, so I'm entering the values. Now we have a sense that it will converge very slowly. So I'll just scroll down very fast. This computer will work for us. Okay, so there we go. So we have 1 over this quantity times square root of the ln of this quantity. Okay, and there we go. And then we have what this, so let's scroll down. Okay, all right, we will scroll down and we go ahead and let's see. Yes, I think we are here, right? So okay, we think we can go a little further up just for, so I think n equals, or capital N equals 408 should be sufficient for our purpose. Okay.